We're going to put the Worldwide Bearing ceramics in there. They have a special low friction grease and they work really well. Here's the other thing. So there's lots of different ways to do this. You can get special tools from your dealer here when you purchase a set of, let's say, BST wheels and we install the bearings. We've got all kinds of special tooling. What I'm going to do right now is on the front wheel, I'm going to do this how you would probably do it in your own garage with limited tools and limited abilities. And I'm going to show you the best way to install ceramic bearings without causing yourself any grief and without having to buy a bunch of special stuff. Hopefully. I haven't done it on this bike, but they're all pretty much the same. So I'm going to get set up and I'll show you what we're doing here in just a couple minutes. All right, here we are. Got something down here so we don't scratch up our wheel or beat up our knees. You're in your own garage, you're having fun, music's on, baby's crying, wife's screaming. Take all that out of your mind. We're gonna have fun with bikes. So first thing we're gonna do, we're gonna pull out this OEM dust seal. And we're not gonna be reusing these dust seals. All I really need to do is take some type of implement of destruction. Used to love Craftsman tools because if I broke their screwdrivers, they gave me a free one. Not sure why they're out of business now. But what we're going to do, see if I go up like this and I just pry down, well, the screwdriver is going to be on the edge here and it can end up nicking up my rim and causing me problems to put my bearings in. So I'm just going to take something, anything, doesn't matter. Then come in here like this, go in. Boink. Gone. Now you can see we also bent it up. We're not using it again, we don't care. But what that does is exposes the actual wheel bearing. Same deal. I can spin this, but there's quite a bit of tension in there. But getting ahead of ourselves. Let's pull that other dust seal out. There we go. All right, so both of these are out. Now, if you put this wheel, everything back together just like this, you would have eliminated this much resistance. Big deal? No. But as we've talked about, we do a little here, little there, little here, little there. These little things will add up to something we can measure. So, now, what do we have to do? Well, now we have to get these bearings out. There's also special pullers for those. You can put them in there and it's like a slide hammer. We're doing it simply. All right, so we're not going to use a bearing puller or anything fancy. We're going to use simple stuff, simple tools like you would have at your house. What we're going to do is try to push the bearing out from the opposite side. So what I've done, got my 2x4, got my nice little microfiber here, and all we're trying to do is see how this bearing can come out about 1/4 of an inch. Currently it'll come out up to here. If we have it laying flat on the ground, we can pound on it all we want. It's not coming out. So that's why we're going to try and raise this ridge up off the ground a little bit. And then if you can see in here, this is the bearing sleeve and they move around, right? Sometimes they don't move, which means you have to knock the bearing back a little bit just to be able to get them to move. But if you can see, I don't know, can you see that ridge on the other side? What we're trying to do is get to basically the inner bearing race on the other side and tap it and then try to tap that bearing out. So that's what we're going to try and do here. You can do this, I'll usually try and use a socket. If you've got a metal tube or a pipe or whatever, the biggest thing is you're going to need to be able to get in here, move that sleeve out of the way so that you can get a good hit on the other side. So what I'm doing, basically I've got this in, I'm side loading it. You can see this extension is no longer an extension. It's been hit many times, and we're just going to come here and see if we can tap that out. Now that is going way too easily, which tells me I missed it. I'm going to get in here, side load this a little bit. So what we're trying to do is just get that to move. easier when it's towards you. All right, I don't like how this is working. I'm gonna go find something else to push down in here. This is actually a little soft. It's moving a little. Okay guys, so what I did, my screwdriver collection isn't working. I had a piece of round stock laying around. Like I said, you can use any kind of tube, but what you need something that has sort of a sharp edge on it, and I'm going to try and get this sharp edge right on the edge of the bearing and try to pound it out. All right, there we go. The bearing's almost out. They're really easy once you get on that ridge. Okay, this is very important. Drips of sweat, cursing, completely normal, part of the process. We just edited out the cursing. Got kids watching, you know. So I'm just going to very gently move side to side. All right. So when we lift this up, we got our bearing. As you can see, the bearing only has a seal on one side. This is our bearing sleeve that goes in here. It's what the bearings squish up against. But now what we're going to do is get this one out, which is much, much easier. Because if you look down in there, you can see plenty of bearing. Just use my socket here, get on the edge. Here. All right. Now, same deal. Pop the bearing out. Now, these bearings, would they be reusable? They could be, but here's the problem. Whenever you press on the center of a bearing race, hammer on the center of the bearing race, it's the equivalent of trying to disassemble the bearing. By pressing on this and hitting on this, you can not only damage the inner race, but you could also damage the ball, which would cause them not to spin. And if you've ever pulled a bearing out that had a flat spot and you can just sort of feel resistance, more than likely it's been damaged some way that way. So what we're going to do, we're going to get this thing ready to put the ceramics in. Hopefully I can find the right around the garage hand tools, and then we'll talk about these bearings a little bit more when we get everything all set up. All right, guys, just as a matter of having experience with these kinds of things, remember, humans put these things together and they send them to you. We try not to make mistakes, so does Dave, but that doesn't mean we can't do a real quick check here. So we take the stock bearing, looks like we're at 14.95, take the ceramic, 14.95, check the OD of stock, 51.97, OD of the ceramic, 51.97, and then just check the center. Stock looks like 24.99, 24.99. Okay, so these are the same, physically the same bearings. Now, you'll notice on the OEM Suzuki bearing, it only had a seal on one side. The worldwides usually have a seal on both sides, and the reason for that is on this particular wheel, there's no way for water to get in from the center of the wheel. So they don't need a seal on this side, saves them a little bit of money. On some other wheels, water can get in from the inside. That's why Conforti seals, Conforti, Worldwide Bearings, David's a good buddy of mine. He seals both sides so that we don't need the dust seals, don't need to worry about water getting in when we're riding in the rain or whatever. So all right, so let's push this aside and sort of talk about what we're going to do here. In the old days, one bearing had a very distinct ledge, and the other times the bearing or the bore may not have any ledge at all. That's what we call the floater, and it takes up manufacturing tolerances. These days those tolerances are so close, in order to know which bearing goes in first and settles up against this shoulder, we looked at our manual. Manual says it's the right side bearing. We know this is the right side. Wheel spins this way. So that means this bearing will be put in first, then the sleeve, And then the second bearing will be put in to just go in and touch the sleeve. It doesn't necessarily have to touch the other shoulder. Like I said, they're getting very close on their tolerances, so sometimes they do. But anyway, for the moral of our story at the moment, this is the right side. We're going to go ahead and lay the wheel down flat, wipe out anything. Now this is a brand new bike. Your bike's probably going to be dirty. Take some brake clean, get everything out of there. Same thing, just clean these up. Some guys will lube them. I haven't really found the need for that. All right, so if you have your service manual open, you're going to see this vast array of special tools you can purchase. And one of the things that the special tools do is prevent you from hammering on the bearings. It's basically a threaded rod, some nuts, and some other things. You can buy those tools, you can make them yourself, or what I'm going to do, I found a socket that just barely fits in through here. When I say just barely, that's very important. Because what that means is when we go to tap this bearing in, we're only tapping on the outer race. If we tap on the outer race as opposed to the inner race or anywhere in here, we don't run the risk of damaging the bearing. So it's really a pretty straightforward deal. So I put it there, get it started. I'll usually take a plastic hammer and just sort of, and I'm tapping on this outer edge. And I managed to get the bearing really sideways. Hey, this is real stuff here. So what I'm going to have to do is just sort of gently go in here, touch off the outer race. It didn't even hardly start in. And we're going to try that again. It's actually a little easier to get down here to ground level. Now, we got it started. It's going in straight. We're just going to take our tool here. You know, just as something to mention, you can also use the old bearing. It's just sort of hard to hold it in place. So, and you got to watch, if you use the old bearing to press it in, you may end up pressing the old bearing in, and then you got to worry about getting it out. So anyway, we're going to go back to our tool here. As I mentioned, we're only tapping on this outside edge. Alright, so now you can see the bearing's going in. And since we're putting this bearing all the way down to that ledge, we're going to go down and it'll actually make a sound, a nice solid sound, so we know that it's gone all the way down. Solid. So we are down. We'll go ahead, flip this over, and just sort of inspect down in here, see whether or not we went all the way down. I'm gonna go out on a limb and say we give it another tap or two. All right, solid. Once we know that one's in, come over here, we put our sleeve back in, slide right down in there, and then that sleeve and this edge should be really close. So all we're going to do is push that bearing in until this sleeve and the inner race just barely touch. I'm excited to show you the tools we use. You can do this stuff. If you're on the side of the road, you can swap a wheel bearing this way. So still in our garage, music's playing, having fun, little cursing. Now we also want to make sure that we didn't accidentally nick up make sure we didn't nick up our sleeve when we were pulling it out. No problem. Yet again, we're lucky. We have a brand new motorcycle. Makes this quite a bit easier from a cleanup standpoint. This can get tricky. And I say this can get tricky. On some wheels, you don't have this ledge to stop the bearing like I was telling you about. So if you go in and pound this bearing and that sleeve, it's actually going to run the risk of pushing this bearing out of place. And you don't want that. So if you can take the old bearing and just sort of stick it in here, if it's not going to get stuck on you. You can also take your old bearing, put it on a belt sander just to make it a little bit smaller so it'll stick down in there. But what that'll do is raise it up off of the surface. I'm going to try and do it without that because I don't have my belt sander handy, and I'm sort of daredevilish that way. Down here and just sort of. What we're wanting to do is make sure that we're only going down to this sleeve. Alright, so what I'm doing now, I'm just very slowly tapping this bearing in so that it just touches this sleeve. So we don't want to push that other bearing out. I'm close. Alright, did you hear that sound? That was solid. So we're right on the edge. So what I'm going to do, flip the wheel over, make sure this one is definitely seated. Alright, and we are right on the edge. Alright, so I can feel, if you look in here, I can feel this, the edge of this sleeve, the inner sleeve just touching this bearing. I can't move that back and forth. We are feeling much better. A lot of you laughed at me because of the way we did it last time on the floor. Was trying to duplicate roadside or just hang out at home repair. So what we're doing now is we're going to come here and we're going to show you how we do it at Brock's Performance. We have quite a bit of experience installing wheel bearings here at Brock's Performance. If you want to check this out, these are all bearings from Worldwide. When you order a BST wheel from Brock's, you get the choice between either a steel bearing or a ceramic bearing. And we install them here. So we know a lot about carbon fiber wheels too. So what we're going to do, I'm not going to bother you with taking out the seals and that kind of stuff. You know how we did that over the last video. But I am going to show you how we put the ceramic bearings in without running the risk of damaging the bearings whatsoever. I know you liked my rag screwdriver and wood last time, but this is actually the tool for pulling these seals. So you get in here and done. No seal there, so we don't have to worry about it. Of course, there will be one on the sprocket carrier. Okay, bearing extractor. Basically what you have here is an expanding collet. You can see this little lip, the little lip right here. We're going to take that lip, put it just at the intersection of the bearing and the tube, and tighten it up. Crank that down. Fun part. What we don't want to do is get all excited and start yanking up like this with our light above us. Don't ask me how I know that. All right. See how much we've moved already? Much easier. Still a little sweaty, not nearly as much cursing. Ta-da! Now, this is very special. We occasionally have people put their ceramic bearings in. And when I say ceramic, the races are steel, the balls are ceramic, it's a hybrid. So, but the term for it is ceramic. When we have people put their own ceramics in, occasionally they'll leave this crush tube out. And as you saw from the last video, if you leave the crush tube out, you go to tighten up your axle nice and tight, the spacers press on the inner races, and you crank them down nice and tight, take your bike for a ride, and those ceramic bearings start burning into that steel race like a hot knife through butter. It tears stuff up almost instantly. The same goes with the spacer between the bearing and the sprocket carrier. So make sure that you put the parts back in. This particular part, there's no right or wrong way, either way to go back in, but definitely don't forget it. See where that lip caught the inside of the bearing. Alright, one bearing out. We're going to set it here with the seal because we're going to measure it. Now let's get this one out real quick. Ta-da! Easy stuff. Just gonna set this aside for now. I grabbed the sprocket carrier here, and same thing, we've got a lot of seal resistance here. We're gonna go ahead and pull this spacer out, set it with our other part. Now, the spacer I was telling you about, it's right here. And it can only go in one way. You can't put it in backwards and still expect the wheel to go together. But this is critical. You can leave this out. And if you leave this out, it'll leave an air gap between this bearing and the bearing in the wheel, and it'll tear this carrier bearing up in a hurry. So make sure you always put this spacer back in. Now, if you look at this, obviously we can't push the bearing out this way, but we can push it out this way. So that's what we're going to do. These can get a little bit tricky because the same thing, if I flip this over in the press and start pressing this out, the furthest I can hope for it to go is on the edge that it's resting on. So we'll show you how we deal with that. Okay, so what I'm going to do here, we've got a nice little piece of nylon that'll keep from marring up this surface. I'm going to go ahead and tap this bearing a little, get it out as far as I can. All right, there's that solid sound, which means we know that it's that far. So now we'll just come over here, give us a little bit of extra. Easy stuff. So there are our stock bearings. We're going to do the same thing that we did, but I want to mention something here. Our front bearings and our rear bearings are almost the same. On some bikes, the bearings will be exactly the same on the thickness and the OD, but the ID is smaller or larger because of axle size. Front axle is typically smaller than the rear, of course, on most sport bikes. So you can put these bearings in, you get 4 bearings, they all look the same, you pound your bearings in, and your axle won't go through. So you call us up and go, Brock, I bought bearings from you and they don't fit. And we say, ooh, does one axle fit through? And does your rear axle fit through your front wheel and or vice versa? Then you put the bearings in wrong. So just a really little quick deal just to make sure we're doing exactly what we're supposed to be doing. And you saw me do this in the last video, so we're not going to bother you with it, but you get the idea. I want to point something out to you. When you purchase a worldwide bearing, it's not uncommon for you to have a small amount of travel in the inner race. I'm sure you've heard your friends say, well, I don't buy bearings from my dealer. I just go to the local machine supply center and buy me a bearing off the shelf. And that will work. But let me tell you why worldwide bearings have a little bit of play in them. Just like everything else, the best testing of a high stress application is racing. These bearings have been tested to 367 mile an hour, I believe it was, on the Bub 7 Streamliner. And I know my buddy Bill Warner, God rest his soul, went 311 on his turbocharged Hayabusa. Well, let me tell you what happens when you start spinning a bearing at a wheel that's going over 300 miles an hour. Pardon my scratch here, but if you can imagine, you've got your balls here and you got a lot of heat. This is your gap. So what happens is, as you're going faster and faster and faster, the balls and everything can really thermally swell. And what will happen is they'll swell to the point where they're actually touching in here, and you'll get a little line in the center of the ball. Well, that's friction, and as you know, we're trying to cut down on friction. Imagine what kind of friction you're getting when your ball bearings are grinding against themselves at, however many hundreds of mile an hour. So if you feel your worldwides and you think, wow, I don't think there should be any play in there, it's in there by design, and believe me, you can't feel it on the bike. Dave intentionally sizes these things. We've tried them super loose, and even super loose in road racing, the guys say that they can barely feel it. So he's reached a nice medium. We don't have to really custom fit now for applications. All of them work really well. It's a really, really nice product, as I've been telling you. Now, fixturing. We're going to take this over, and instead of beating it in with a socket, we have an assortment of different fixtures here at Brock's that we've designed to do tasks like this. So let me show you what we've got. come here, set the bearing in straight, set it up, get it set in the middle here. Once again, we're pressing primarily on the sides. We want to be centered up, press on this outer race, make sure we don't have everything all jacked up out of square. Alright, my gauge started to move. Now I'm going to come over here by hand, give it a little, back it off, turn it 90 degrees. Alright, installed, nice and straight, bottomed out, ready to run. We're going to go ahead and put our spacer back in here so we don't forget it. Let this just sort of hang out for a second while we put the bearings in the wheels. Now, one of the things I want you to notice about the wheels, what I was talking about by sanding the outside of a bearing to hold the wheel up. If we press our first bearing in, then put the wheel down like this, the only thing touching is the bearing. So when we go pressing the second bearing in, it's not possible to force the first bearing out. This is all designed this way intentionally. Here at Box and works really well. So I've got to reset our press here, and we'll do that in a second. Okay, we've cleaned everything up. We've cleaned up the wheel. I looked in the manual. This pocket is a little bit shallower than this one, but I double checked. Suzuki says to put the right side bearing in first. We know that's the case here from the rotor. So what I'm going to do, I'm basically going to press on this flat surface here. So I'm going to put it on top of this plate. I won't need that for now. And then we'll set that down and we'll press the first bearing in. And I finish it off by hand here. We also have a pressure gauge, so I know that I'm pretty close, but I like feeling it. Yeah, it feels solid. And you can see, press down in there real nice and straight. So here's the cool part. Lift this up. I'm going to put this spacer back on, and if you notice, this spacer is a little bit smaller than the hole. So I'm going to put that on, and now, okay. It's very difficult to see, but you can tell the brake rotor is not on the plate. So what's happening is the whole wheel is only resting on the face of that bearing. Now, don't forget our sleeve, and the post we just had in there does a really nice job of holding it in place. Centered up real nice. Grab our bearing. So of course I don't have to waste all this time. I can put whatever I want in here as a shim to speed things up, which is what we do here during the day when we're doing a bunch of wheels. All right. All right. All right. Back over here. There's plenty of lube in here. Sometimes I'll WD-40 these just to make this slide back in. We want to make sure that we're not too tight on our bearing. It's a little tight right now. And believe it or not, give it a quick tap with a plastic hammer. Oh, it's too heavy for me to spin, but I can feel the spacer. It's just barely touching now, and bearing's nice and smooth. So